Welcome to problem 714 on page 238. The major difference between this and the previous section was we're dealing with proportion. Now, proportion always uses z-scores, which will become more important as we move through the course. Identifying when to use z and when to use a new concept called t, or t-values. In this particular case, we have two candidates in an election. And it's viewed that if at least 55% vote for one particular candidate, they'll be considered to be the winner of the election. So these are for doing predictions. And you do a sample of 100 voters. So in this particular case, what you can see on the screen is, what is the population percentage of her vote is 50.1. It's trying to find out what's the probability of her winning the election is what we're trying to do. So if she currently is polling at 50.1%, you need to find the standard deviation of that. So the standard deviation for proportion is, you take, it looks like the pi symbol, you take the percentage, you multiply by 1 minus the percentage, you divide it by n is the sample size, and you take the square root. So the very top line where you see the standard deviation of the proportion, so you take and you can see how the numbers work. So you take 0.501, multiply by 1 minus 0.501, and multiply those two results together, divide it by 100 and take the square root, and you get 0.05 as the standard deviation. So the mean of the proportion is 0.501. So you find out the z-score, you get the z-score of 0.98. And remember, to win the election, you have to be to the right. So a z-score of 0.98 will give you a p-value of 0.8365. And you're trying to find the area above the 0.8365, and you subtract that from the 1, and you get 16.35. So there's about a 16% chance that this person will win the election. Now, because remember, you have to have 55%. So in this particular case, in part B, what if her vote is 60%? So you recalculate the standard deviation, plug that into your formulas, use that, get a z-score, in this particular case of negative 1.021, which is 15.39%. You subtract that from 1, and it gives you an 84.61% chance. So if her polling numbers are 60%, doesn't guarantee she's going to win, but she has almost an 85% chance that she will win. What is the probability that she'll actually win if her polling number so that she has 49%? So in part C, once again, you calculate a new standard deviation at 49%. You find out the z-score of 1.2, and you have an 11.51% chance that they're going to win. So recording this in October of 2020, and there's a US election coming up. And when the US election was in 2016, projections showed that Hillary Clinton had a 92% chance of winning and Donald Trump had an 8% chance of winning. Well, we all know what actually happened, and people are thinking that that might happen again, because at this particular point, Joe Biden, in this case, has a significant lead on Donald Trump, but things can change, and just because they have a lead of 17 points or 11 points does not mean that they're going to win. There's still a probability that Trump will win, and there's, even though it's less than Biden because he has lower numbers. So in part D, increasing the sample size, all right, to 400, and we redo A through C in this particular case. And we wind up with a different set of numbers. It gives us more accuracy. So you can see that if the person has 50.1%, now there's a 2.5% chance that they'll win. Remember, they have to get to 55. In part B, it's a little hard to read. It got cut off a little bit. But you can see that if they're at 60%, they're at 99.73 or 99.74. And in part C, you can see that if they're at 49%, they have less than 1% chance, 0.0082. So if you read the very last portion here, the sample size is increased to 400. A, B, and C is smaller, right? So in this particular case, or larger, smaller, larger, smaller, sorry. And because the sampling error of the distribution becomes smaller, and hence the sampling distribution is more concentrated around the true population proportion. A fancy way of saying the larger the sample, the more accurate your results and your predictions. So if you go and sample 4 people, and you people know this, you go and sample 4 people on what they think about a particular course or Mount Royal in general, you'll get a result. You go and sample 100 people, you'll get a result, and that result will be more accurate. You go and sample 400 students, and you're going to have an even more accurate result. Yeah, you go and sample 4,000 students, and you're more likely to come up with the correct answer. So it just improves your accuracy. Long, fancy statistical way of saying something that should be much simpler. The larger the sample, the more accurate your predictions.